Hey guys, welcome back to the AP3X Institute of Mathematics. We are learning the language of the universe begins here. My name is Akini, your math instructor, and in today's video, we are going to be looking at an end of term exam that I had constructed for my students, and I thought that a few of the questions were worth talking about. These questions are CSEC based questions, and they, of course, definitely will improve one aspect of your mathematical skill. All right, of course, this is a video that is made specifically for my students, but of course the questions are quite helpful to the wider audience should in the event that you end up doing a question like this or anything that is of similar nature. Of course, to be notified of the future tutorials that are coming up in the month of January and for the rest of the year that will help you to prepare for your exams coming up in May, definitely want to smash that subscribe button below and turn on post notifications turn on all post notifications to be notified on a weekly basis whenever I post contents related to the CSEC, CAPE, or the various examination body in the Caribbean. All right, so without further ado, we're just going to jump right into the lesson, and we're going to take a look at some of these questions and see how best we can add some more value to our mathematical skill. All right, so here we go. The end of term exam consists of the following questions, and we're going to jump right ahead into talking about question 1 here, which asks us to evaluate 75.18, take away 3.26 multiplied by 9.27, and we are to leave our answer correct to 2 decimal places. All right, so here we have it over here. That is 75.18, take away 3.26 multiplied by 9.27. So never take these questions for granted. Very simple, but at the same time, I find that a lot of students, including my students, they tend to always evaluate whatever they see appears first. And in this case here, we are going to be required to actually multiply first. We're going to have to apply the principle of PEMDAS here. So this means that we're going to have to be multiplying first. I find that quite a few students were actually subtracting first, and that was not very good at all. All right, so we definitely don't want to do that. We definitely want to multiply before we actually add or subtract. So here we go. So if we were to multiply, say 3.26 multiplied by 9.27, we should write 75.18 here and take away the result of this product. So that's 30.22. And if you go ahead and you use your calculator and you were to subtract both of these numbers, you'll find that the answer is 44.95 if you were to round it off to 2 decimal places. All right, so if you're working with me and you have gotten that correct, then you are off and running and you have gathered your first 2 marks. Let's move on to the next question here, which is a fraction. And then again, this is another test to see if you have remembered that even when you're not arithmetically calculating something, then you have to at least still apply the principle of PEMDAS, because it applies right throughout. You must always follow the laws of PEMDAS, or what mostly commonly referred to as PEMDAS principle. So here we are adding and we are multiplying 2 fractions. Both operations require different methods, so that would simply mean that we have to follow the PEMDAS law by multiplying before we add. So once again, we have to go here and we have to multiply first. Now, before we go ahead and do the process of multiplication, we must convert all our mixed fractions to improper fractions. So here we start off by saying 9 multiplied by 3, that's 27, and 27 plus 4, that is 31 divided by 9, plus 36 times 1 is 36. 36 plus 5, that gives us 41 over 36, then we're going to multiply this now by 5 3s is 15, and 15 plus 3 is 18 divided by 5. Once again, as instructed earlier, we're going to multiply first. So we would then rewrite the 31 over 9 here, and we're going to wait for the result of the product here. So when we're multiplying fractions, we're looking for common factors that can reduce either the denominator or the numerator or both. So clearly we can see here that 18 is divisible into itself, and 18 divides into 36 twice. So there is nothing else to reduce. We're going to be left with a result of 41. That's going to be 41 times 1, that's 41. And that is going to be over 2 times 5, which is 10. All right, let's just get that 2 out of the way here. That's 2 here. All right, and then we proceed now. Because we're adding, we're going to be required to find what is known as the lowest common multiple. So the lowest common multiple in this case here is going to be 90. And then we proceed. 9 divides into 90, or 90 divided by 9 gives us 10. We'd multiply the numerator by 10. And 10 divides into 90 goes 9 times. We'll multiply the top here by 9. Now 31 times 10, that gives us 310. And 9 times 41, I believe that will give us 300 and let's see here, 69. Now when we add those two numbers now, we should get 679 divided by 90, but we need to write our answer as a mixed fraction in its lowest term, or write the fraction to its lowest term, which is as a mixed fraction. So if you were to make an estimate here, 90 should go into 679 approximately 7 times. And there's going to be a remainder of 49 divided by 90. All right, so that there goes your solution to your problem. All right, now we then proceed to the following question here. We're going to be looking at this part C here, and let's read. It says here, if a customer is charged 12.5% tax on the cost of an item valued at $400, determine the final cost the customer has to pay in order to own the item. All right, now there's a couple of ways that we can actually do this, and I like when I'm doing my videos, I like to show you variations, different ways to approach the question. And so as a percentage, we know that tax is an additional charge that's going to be added to the cost or the value of an item or a product. So we know at the end of the day, once we find the tax that needs to be, the tax that is charged on the item, we're then going to proceed to add that back to the 400. So there's a couple of ways that you can actually do this. Let's have a look at both methods here. So the first method here is to actually convert the mixed fraction here to a decimal, and that would have been the easiest route. So that would have been 12.5 as a decimal is 0.5, so that's 12.5. As a percentage, we know we divide by 100, and then we are going to multiply the result by the cost value, or the value of the item or the product. All right, so in this case here, we can cancel out a couple of zeros here. Zeros cancel 0 here. And then mathematically, once you multiply 4 by 12.5, you should end up with $50. All right, so therefore then, in order for the customer to own the item, they would have to pay a total of 400 plus the tax, which is then equivalent to $450. That's pretty easy. That's one way of looking at it. Another way that we could actually do this here is to actually convert the mixed fraction here to an improper. So we could therefore say 2 multiplied by 12 is 24, and 24 plus 1, that's 25. So that's 25 over 2. But remember that as a percentage, we still have to divide the result by 100. So So that's 25 over 2 divided by 100 multiplied by the value of the item or the cost of the item, which is 400. All right. Now, since as the 2 here is a denominator and the 100 here also is a denominator, then they basically become common denominators. So we could look at this and say this is 25 over 200 instead, multiply 400. And so if we cancel, say 200 into itself one time and 200 into 400 twice, you'd find that 25 times 2 gives us a result of $50. And once again, the final result would have been 400 plus 50, which is equal to $450. All right, that's method 2 of approaching the problem. And it's good to have variations because everybody learns differently, everybody sees the question differently. And of course, one of my favorite methods to use here is where I add the percentage tax to the original cost of an item. I know personally that the cost of any item as a percentage is 100. So if I were to say perhaps add the 12.5 here, that's 12.5 to 100, then I know that the final cost of the item after tax has been added would have been 112%, 112.5%. So if I were to say 112.5 divided by 100 and then multiply this now by 400, then if I cancel here 104, if I multiply 4 by 112.5, I'm going to get the final result here of $450. All right. So there's a couple of ways that you can actually approach this very simple problem. 3 methods, and there could be other variations in which you could do it, but for now that's just the first 3 methods that I saw there that could have worked out for this particular problem. All right, so hopefully that makes it a little bit clear for you. Let's go on now to the other part of the paper. So now we're approaching here part D, which is the ratio aspect of the exam. And so we're going to just do that working out here in this section of the paper right here. And then we're perhaps going to have to do a little bit of erasing. All right, so here we go. It says here that a sum of money is to be shared among 3 siblings. That is Dwight, Conrad, and Bunny. Those are the 3 siblings in the ratio 5 to 3 to 9. Now, Conrad received $345.67 less than what Bunny had received. Now, there is a 3-step process that I often explain to my students that you ought to apply whenever you approach a ratio question. Regardless of the structure of the question, these 3 steps always seem to appear and they always seem to make the process easier. Now, the very first thing that I encourage you students to do, near or far, whenever you see a ratio question, the first thing that you want to do is that you want to make sure that you write down who are the persons involved in the ratio. Now, in this case here, we are looking at Dwight and Conrad being compared to Bunny. These are the 3 persons involved in the entire ratio. And of course, that is step 1. Then we're going to be writing down what are their individual shares. What shares did they get from the total sum of money that is being distributed? So Dwight got 5 portions, Conrad got 3 portions, and Bunny got 9 portions. Now, it is very, very important that regardless if it is that you're going to be finding the total amount of money that is being shared or not, you still always want to have in your bag the total proportion, meaning that we want to find out how many parts does this particular money that is being shared has. How many parts does it have? Now, we know that total proportion would be that we're going to be adding the 5 plus the 3 plus the 9, which would give us a total value here of 17. So whatever this amount of money is, let us just say that the money that is being shared here is X. We know that this amount of money has 17 parts. Now, mathematically, using the direct proportion principle, if it is that you can find one portion, if you can obtain one portion, then you might be able to find 100 portions, 200 portions, 50 portions. As long as you're able to identify the value of one portion of this money, then you should be okay. Now, in order for us to do this, we're going to have to go to the part here at the bottom that says that Conrad received $3,345.67 less than Bunny. Now, I find that a lot of my students, when you're actually working this problem, they tend to always read the question, and what they'll do, and what I find a lot of the times, is that they tend to divide the amount of money that they see right here by the amount of shares that Conrad received, which is, so I find that a lot of persons divide the 3,345.67 by 3, when in fact, remember that the question actually stated that Bunny received that amount less than Bunny. So that's not the amount of money that Conrad actually got. He just got this amount less than what Bunny actually received. So now we're going to have to do something here, something a little creative here. We're going to have to focus on what is here. This is the focus of the question, Conrad and Bunny. There's a reason why Conrad had received less money, in this case 3,345.67 less than Bunny, because the difference between the amount of money and shares that Bunny received over Conrad is that it is the difference between the shares is equal to 9 take away 3, which now works out to be 6 shares. So therefore, the reason why Conrad is getting less money than Bunny, it is of the simple fact that Bunny had 6 extra shares than what Conrad had. So now, since it is that Conrad received $3,345.67 less than Bunny, we would therefore then take the amount of money, in this case here, 3,345.67, and we would then divide it by 6. That would then produce the result of one portion. So then let me go on my calculator here. I had done the problem earlier, but let's just make sure that we write 3,345.67 divided by 6. That produces a result of 557.6. So that's 567.61 cents. All right, that's the value of one portion. Now, once we know what the value of one portion is, then we can proceed now to answering question 1. Question 1 here says that the total amount of money that was shared between the siblings is actually, here they say total, so we know that the total proportion is 17. So the total value here is 17 multiplied by, let's put it here, it's 17 multiplied by 557.61 cents. And that will give us a total of, let me just pull that up. So that's multiplied by 17. And we should get a total of $9,479. And of course, 39 cents, rounded off to about 40 cents. All right. So that would be the total amount of money that was shared between all 3 siblings. Now, here I put a little twist to the question. Usually we would ask Bunny's share as a percentage of the total, but what I did here is that I made a little twist to it here. So what I did is that I tried to compare the amount of money that Bunny received in comparison to what Dwight and Conrad received together. So there's a couple of ways that you could do this, and due to the fact that I don't have a lot of space, I won't show you the longer version. I'll just show you the easier version. Here, I would just use the ratio that I currently have here, and so Dwight and Conrad's share together will sum to 5 plus 3. So Dwight and Conrad would have received 5 plus 3, which is 8 shares in total. Alright? So Bunny, compared to what those two guys received together, would have been 9 shares received by Bunny divided by 8 shares received by Dwight and Conrad. And as a percentage, you're going to multiply it by 100. And if you go on your calculator, you'll find that the answer is approximately 113%. All right, that's the easiest way to do it. Now, an alternative is to actually find out how much money Dwight received, find out how much money Conrad received, add them both together, and of course proceed to find out how much money did Bunny receive, divide both numbers, and you'll find that the answer is still 113%. All right, so definitely you want to make certain that that is something that you attempt to see if you're getting the same result. Okay, and just to wrap this up here, guys, we're looking now at the total amount of that Dwight would have received if he gave away $350. So we already know what is one portion, and we also know how much portions Dwight received. So I can definitely go ahead now and find out that Dwight would have received. So Dwight here would have received 3 multiplied by 557.61, and on my calculator here I would see that Dwight would have received, let's see here, 2,700, and just give me a second here, guys. Okay, here we go. So that would have been here 3 multiplied by 557.61. Is that it? I think, oh no, Dwight actually got 5 shares, pardon me. So it's 5 multiplied by 557.61. So he would have received 2,788.05. So that's the amount of money that Dwight would have gotten out of the 9,479.39. But he actually gave away $350. So if he gave away $350, then if we subtract $350 that he gave, then his final balance that he would have had would have been $438.05. And that pretty much ends that aspect of the question. Some knowledge there, guys, on that. And then we are now going to proceed now to working out the remaining questions that is on the exam paper. Okay, so let's get to that right now. All right, guys, so we're just gonna move on to the next question here, which is of course the measurement question here. And it says here that the diagram below, not drawn to scale, represents a wedge. Just give me a moment here, guys. Let me turn off my notifications. Okay, here we go. We're good to go. All right, so the diagram below, not drawn to scale, represents a wedge that is in the shape of a triangular prism with a length of 21.5 centimeters, cross-sectional dimensions of 6.8, 8.5, and 3.4. And of course, using that information, we are to do the following: calculate the volume of the wedge, the surface area of the wedge, and the total surface area of the wedge. All right, so I'm just going to go across here to draw the diagram that was given to the students. All right, and the diagram that we are actually looking at here is a diagram that looks like so. Give me a sec here. All right, so here we go. Okay. All right, so the diagram that we're actually looking at here looks like this. Here it's a triangular prism. Not a very good artist. Okay. It looks something like that. And let's do some background drawing here. Like so. Like so. Like so. And so. So that was the diagram that we had, all right? And so what was told to us is that it has a length of 21.5 centimeters. And it also had cross-sectional dimensions of 8.5, 6.8, and 3.4 centimeters. So that was this diagram that we were looking at. And so just to remind you that the cross-sectional area is right at the face here. This is the face of the diagram. All right, and there's always two of them, one at the back, one at the front, or top and bottom, or left and right. So in this case, it's front and back. All right, now we are to use this information here now to actually determine the volume of the wedge. All right, determine the volume of the wedge. Now this goes back to us knowing the formula for volume, and so volume is equal to the base area, or the cross-sectional area I should say, multiplied by the height. Oftentimes you'll find that they say V is equal to AH. All right, so the A would stand for the base area, or the area of the cross-section, multiplied by the height. So in this case here, the base area here would have been a triangle. And so specifically, the triangle that we're looking at here is a triangle that has all three sides given to us. And so there is a special formula that we use when it comes to finding the area of a triangle that consists of all three sides. And that means we're going to have to resort to the Heron's formula. So that's the Heron's formula. All right, let's here. So that's Heron's formula multiplied by the height, or in this case it will not be a height, it will be a length, because the wedge is actually lying down on its side. All right, so it's just again times the height, which is the length, basically the same thing. Okay, so we're gonna have to do a little bit of extra work here, because Heron's formula, A, is actually the square root of the semiperimeter S multiplied by the semiperimeter minus each length all right, and so we're gonna have to do an additional working out here where we're gonna have to find S. S is equal to the sum, or it's the perimeter of the cross section, divided by 2. And so you must be familiar with this formula, or else the problem is going to be almost impossible for you to work. All right, so you have to be familiar with Heron's formula, when to use Heron's formula, and of course how. So here is the working out for Heron's formula. We're going to have to find S first. And so S, which stands for the semi-perimeter, is going to be 6.8 plus 3.4 plus 8.5 divided by 2. All right. Now, if we proceed to add all three of those numbers, you're going to find that the answer here is 18.7 divided by 2. And this works out nicely to be 9.35. All right. Now, it is okay if, well, there is no specific instruction that says that you should have it to 1 decimal place or 2 decimal places. I find it a lot easier if you just use 1 decimal place. It makes the answer or the working out a lot better. But as you would have all known, that the more decimal places you have in your calculation is the more accurate your answer will be. So you're going to fall within a range. But I'm just going to do what exactly that my students did. They actually used the 9.35 here. So we proceeded to say, all right, A is equal to the square root of 9.35, open bracket. You can see here the S is 9.35 and S again, that's 9.35. Take away what we stated to be A, which is 6.8. 9.35 take away 3.4, and then again that's 9.35 take away 8.5. all right, so we're going to go right ahead now and do those little mini calculations here. And so we're going to have that the square root works out here nicely to be 9.35. We know that bracket means to multiply, so we're going to multiply the result of what is in that first bracket here. So that's 9.35 take away 6.8, and that gives us a result of here 2.55. Bracket again means to multiply, so that again is 9.35 take away 3.4, and that gives us 5.95. And once again, that is 9.35 take away 8.5. You find that the answer is 0.85. all right, do remember that we are still trying to find the volume, but because the base area is a triangle containing all three sides, we work out the area of the cross section, and that's what we are currently doing at the moment. So this works out nicely here to be, all right, so that's going to be 0.85 multiplied by 5.95 multiplied by 2.55 multiplied by 9.35, and that worked out nicely to be 120.58. And if we proceed to find the square root of 120.58, we work out the answer here to be 10.98 here. That is 10.98, and its area, so it's squared centimeters. all right, but we're not done. As I mentioned before, that is just the Heron's aspect of it. We now need to take the area. This 10.98 now is the area of the cross-sectional face. all right, so we now need to take that now and multiply it now by the height, or the length in this case, which is 21.5. So if we successfully do that, all right, if we successfully do that, then we'll find that our final result for the volume of this prism here is actually 236.09 rounded off to 2 decimal places cubic centimeters. That's 236.09 cubic centimeters. all right, so let's just make a couple of notes here. all right, remember that this thing here in the red is the area of the cross-sectional face. We might need that a little bit later. So that's the area of the cross-sectional face, and this number here down here represents the volume of the actual wedge or the actual prism. all right, so hopefully you guys got a good understanding behind working out there. all right, so let's just go back now to have a look at the remaining questions. Here we're now looking at finding the surface area of the wedge. So we're looking at finding the surface area of the wedge. So surface area of the wedge. all right, and there's an actual formula for the surface area of any prism. all right, and the formula for that is that the surface area, abbreviated SA, surface area, is equal to the perimeter of the cross-sectional face multiplied by the length or height, depending on the orientation of the prism, then it multiplied by the length or the height of the prism or the wedge. all right, so that is the standardized formula, and a video is coming out soon enough explain to you a lot about the breakdown behind how these formulas are created. So just stay tuned and ensure that you are subscribed to the channel. all right, so now the perimeter of the cross-sectional face, let's just go back to our diagram here and look. Here's our cross-sectional face and we need the perimeter. Now the definition of perimeter means the distance around the face. all right, and in this case all we can do is just simply add all the sides. All right, we can add all the sides here. So that's going to be 6.8 plus 3.4 plus 8.5, and all of that result there is going to be multiplied by the length, which is 21.5. Now we can go ahead and add those, but as you can see, a lot of the times when you're doing questions like these, you're going to find that a lot of the work has already been done. If you look here, that we had already added the 6.8, the 3.4 and the 8.5, and we had earlier gotten 18.7. So if you wish to go ahead and add it again just to confirm, you can, but it's just already done for you. So that's 18.7 multiplied by 21.5. all right, and if we go ahead and punch those digits in our calculator, that's 18.7 multiplied by 21.5, we're going to find that our final result here works out to be 402.05. It is area, so it is squared centimeters. All right, and we can proceed once again now to finding the other aspect of the question. Let's go back all the way to the front here. It says here that we are to find the total surface area of the prism. All right, so total surface area here, total, give me a second here, guys. All right, so we're looking for total surface area here. That's total surface area, and that too also has a formula that we use. And so the total surface area of any prism is going to be the surface area plus 2 times the area of the cross-sectional face. Now, because we have to multiply it by 2, because there's 2 faces of the prism, there's always one at the front, one at the back. In this case, sometimes it's at the top and the bottom, depending on if it's like a cylindrical container, or it could be the back and it could be the side and the side. So in this case, it's back and front. So it's the area of one cross-sectional face times 2. All right. So the surface area is something that we just found. We just attain the result of the surface area, which up here is just 402.05. And then now we're gonna add that now to 2 times the area of the face. Now remember earlier when I told you that we need to make a note of something that we did down here, and I did say to you that this 10.98 here is actually the area of the cross-sectional face. So I had made a note of that because I kind of predicted that we're going to need this information. So there's a lot of times when you're working the math problems, you might have to do the farther down in the question you go is the less working out you have to do, because most of the time a lot of the working out has already prematurely been done. So here we did not work really hard to go ahead and find the area of the cross-sectional face. We would have already had the answer as being 10.98. So if we proceed here now to go ahead and work out this, we're going to have 402.05. 402.05. And then if we multiply here 2 times 10.98, let's just pull this calculator up here. We're going to find that 10.98 multiplied by 2, that gives us 21.96. And if we add that to 402.05, we get a final result here of 424.01. It is area, so it is squared centimeters. You do not want to leave off your unit of measurement. All right, guys? All right, so hopefully that makes it a bit clear for you. Now we're going to proceed on now to looking at the remaining questions. So hopefully you're getting some understanding and it's clear for you guys. Just leave your comments down below if the video is providing you with some value. All right, and do not forget to share this out to other persons who might benefit. All right, So we're going to be looking at part 4. All right, so in part 4 here, the triangular wedge is metallic and was melted to form the shape of a cylindrical container having the same length. Now, you are going to be using the information as given above, and of course, as it says here, it has the same length. You are to determine the radius of the cylinder. Challenging question, but it just requires a little bit of thinking. All right, so let's see here. Let's go to an empty page here and try to interpret what this is saying. So you're basically saying that the wedge that we're looking at here is actually a metallic prism, and so it was melted and reshaped into the form of a cylindrical container. So what would that look like? A cylindrical container has a circular cross section, so it would look something more like, say so. And so basically it's melted and it's reformed to form that shape. All right, it's reformed to form that shape. So now we have a metallic cylindrical container. Now, very important, guys, that you understand that even though the prism has been melted, it has been reshaped, but very important, you understand that they will both contain the same volume. That's very, very important there, right? The volume will not change. It is just perhaps the measurements, or a few of the measurements, or all of the measurements might change, but the actual volume of the prism will not change. So basically what we're saying is that the volume of the triangular prism that we have over here is going to be the exact same volume of this new prism that we just melted and formed. All right, so it's very important here that you understand that the volume would remain constant. Volume remains constant. All right, very important here. All right, now it did say to us that it has the same length. So we knew from earlier that the length of the triangular prism here is 21.5. So we also know that the height, or depending on how you decide to draw it, then the height of the cylindrical container here is also still going to be 21.5. But what is it that we don't have? We actually do not have the radius. So we don't know what the distance from here to here is, and that's what we are in search of. We are in search of R. So now we can actually utilize a formula here, because remember that we're still working with volume. Remember that the volume, as stated earlier, is that it's the base area times height. Now we changed the shape of previously. The cross-sectional area of the prism was a triangle, where we had to use Heron's formula to find the area. Now, the actual area of the face here is a circle. So now V is now going to be equal to the area of the base, or the area of the cross-section, which in this case now is a circle. So that now becomes a pi r squared. And then we're going to multiply the result again by the height. All right, so our formula has changed simply because our wedge has been reformed into something else. So now our cross-sectional area now is a circle. All right, and as you can see here, we are looking for the radius, and in the formula here you can see that there's an r that we're going to have to transpose and make the subject of. All right, so let's go. We did say earlier that the volume remains constant. So if we go back over here and we looked at what the volume is that we had calculated, here we said actually 236 point, I believe this was 236 points, it? Let's double check. I think it was 236.09. Let's double check that and make sure that we are on the right part. That's 200, let's see here. That's 10.98 multiplied by 21.5. 236.07 actually, that's what we got. Well, it's 09 because I had used a lot of decimal places. So 09, 07, 08, we are within a range. So let's just work with 09 as we have it here. All right. So here we go. We know that the volume is 236.09. That is equal to pi. We weren't specifically told what to use pi as. So we're going to work with 3.14. We are obviously in search of r. So that's r squared that remains, and we already know that it has the same length, which in this case now is the height, 21.5. So 236.09, okay, 236.09 is going to be equivalent to the product of 3.14 and 21.5, right? Because r is the subject that we're in search of, so that's going to be 3.14 multiplied by 21.5. That results in being 67.51. So that's 67.51 r squared, because r squared is the subject, or r is the subject. Now, we have to remove the multiplier here, the coefficient of 67.51. So we're going to divide both sides of the equation by 67.51. So that's going to be 236.09 divided by 67.51, and that will result in r squared being the subject. Now go ahead and we proceed to find out what is that thing there. So that's 236.09 divided by 67.51, and we find that our result here is that it is 3.49, or we could just say 3.5, but that's okay. That's equal to r squared. All right. And just to wrap up our final result here, in order to get r to be the subject, we're going to have to find the square root of both sides. So that's the square root of 3.49, and that's going to be equal to r. Okay. Because when we take the square root of r squared, the square will cancel the root. So our final result here for the radius of the circle here, that is here, or the radius of the cylindrical container here, is going to be 1.9. All right, 1.91 centimeter. And that is going to be the radius of the cylindrical container. All right, so that's definitely how you go about approaching this particular problem here. All right, so hopefully you guys got that. Of course, feel free to just kind of rewind the video and listen again until you feel that you have it all packed down. So make a note of that the radius is 1.91 centimeter. All right, let's proceed now to working out the final section of this particular question here. All right. Now we are told here that if 1000 centimeter cube is equivalent to 1 liter and 0.4 liters of water was poured into the container that we now have, we are to determine the height of the water that is currently in the container. Currently in the container. So here we go, guys. We're going to approach that question just about now. All right, so we're going to go over here and get that done. All right, it's the same container that we have here. All right, let's just redraw it on here, this side. So we have our cylindrical container here. Okay. And we're saying that some water was poured into it. All right. Let's just draw a little image here. Okay. So some water was basically poured into the container. All right. We already know that the height of the container is 21.5 centimeter, And we also know that 0.04 liters was poured into it. All right. Now, our volume of the volume of the actual prism is 236.09 cubic centimeters. So we know that for certain the container can hold a maximum of 236.09 cubic centimeters of stuff. The water that is being poured is in a different unit, so we are going to need to do a conversion. All right, and since our dimensions of our prism is in centimeter and the volume is in centimeter cube, it would almost be logical that we're going to have to convert that 0.04 liters to centimeter cube. Now, usually we're not always told what the conversion unit is, but in this case we are fortunate enough to be told that 1000 cubic centimeters is equivalent to 1 liter. So by using direct proportion, we could simply say, okay, then 0.04 liters is equivalent to X, because X is what we are trying to find. We're trying to find how many centimeters cube will be equivalent to 0.04 liters. All right. So if we look carefully here, that liters will cancel liter, and you're going to find that our answer is left in centimeter cube. So X multiplied by 1, if you cross multiply here, X multiplied by 1 is going to be equal to X. And 1000 multiplied by 0.04 will give us a total of 40 centimeters cube. All right. So 40 centimeter cube of liquid was poured into a cylindrical container that can contain or hold 236.09. So logically that would mean that, oh, well, the tank is not going to be that full. It's just going to be a little bit of water that is in the tank. Maybe just about here. Right? Because it can hold 236 and you are only pouring 40 into it. So there's not going to be a lot of water that is in the cylindrical container. So right now, our focus is not necessarily on the volume of the prism. Our focus now is going to be on the volume of the water that is in the cylindrical container here. So what we're looking at here now is the volume, again, is equal to the base area times the height. Water that is currently in the tank is 40. We already established the base area, or did we? Did we find the area of the base? We had found the area of the base when it was a triangle, but we hadn't found the area of the base when it was a circle. So now we need to go ahead and say pi r squared times h. All right. So we know that 40 is going to be equal to pi, which is 3.14. And remember that initially the question had asked us to find the radius, and we had established that the radius is 1.91. There it is. So that's how we know we're utilizing our information that we had calculated earlier. So that's 1.91 squared. And obviously, like before, when we were looking for R was the subject. Now H is the subject. This H now represents the height of the water that is currently in the tank. So if we go ahead now and we were to say 1.91 squared, okay, we'll find that this aspect of it here is 3.64 or 3.65. That's okay. So that's 3.14. That's equal to 40. So 40 cubic centimeters is equal to 3.14 multiplied by the square of 1.91, which is 3.64. So go ahead now, 3.64 multiplied by 3.14. We get our answer to be here 40 is equal to 11 point, let's see here. It is 11.43 H. All right, don't forget our H there. And now just to wrap it up now, just to finally get our answer, we'll realize that H here is equal to 40 divided by 11.43. All right, we're dividing both sides by 11.43 so as to isolate the h. So h here works out to be, let's see here, that is 40 divided by 11.43, and we end up with an answer of 3.49, which is approximately equal to 3.5 centimeter. So basically the height of the tank is 21.5, but basically the water poured into the tank is approximately at 3.5 centimeters. All right, so hopefully you guys got that aspect of it. Little tricky, but very doable. Take some practicing, guys, and hopefully that is clear for you. All right, so we're going to move on now to the other aspect of the paper. Of course, if you're getting some value already from the content, guys, please be sure to smash that subscribe button below and turn on the post notification bell to be notified. These videos are going to be coming out heavy, and you want to stay tuned to get as much practice as you possibly can. All right, so we're going to move on to some worded problems here. I guess you guys would have already had this. Let me just get erase here for you. All right, so here now we're moving on to some worded problems here. A car, I think I should be able to do this question in this section here. So let's go. A car travels 60 kilometers in 1 hour and 30 minutes. How long would it take for the car to cover a distance of 100 kilometers? And this is just clearly an example that requires the direct proportional skills. Now, there's two ways in which you can actually approach this question. All right, both using direct proportional skills. So the first thing that I saw is that I would create a relationship between what I already know. I would say simply here that 60 kilometers can be completed in 1.5 hours. That's 1 hour. 30 minutes is a half of an hour. So that's 1.5 hours. So I'm keeping my answer in hours. All right. I would then create now an unknown relationship to say, okay, then 100 kilometers will take me a distance of, or it will take me a time of an unknown. That's what I'm in search of. Now, if I use the direct proportional principle here and we cross multiply here, we would find that 60 kilometers times x, well, first of all, kilometers will cancel kilometers, so clearly your answer is going to be left in hours. So 60 multiplied by x is 60, and 100 multiplied by 1.5 hours, that's going to be equal to 150 here. So 1.5 multiplied by 100, that gives us 150 here. So if you were to say x is equal to 150 and divide both sides by 60, then you're going to find that your answer here works out to be equal to 2.5 hours. So that's 2.5 hours. 2 hours and 30 minutes is what it would take for you to travel a distance of 100 kilometers. And that's just one way of looking at it. Now, I did find that quite a few of my students took a different approach. All right, so hopefully you guys just saw that method. I'm just going to erase this screen here and show you another way that it could be done. All right, and so what I found that quite a few students did is that they converted the 1 hour and 30 minutes all into minutes. So what they did is that they're like, okay, 1 hour is equal to 60 minutes. And of course, that is going to be plus the extra 30 minutes. So basically 1.5 hours is equal to 90 minutes. I saw quite a few students did that. So they stated that 60 kilometers can be completed in 90 minutes. And they use the principle using the ratio where they find how far or how long would it take to travel 1 kilometer. So 1 kilometer is actually equivalent to 90 divided by 60, and so 1 kilometer worked out to be 1.5 minutes. So to travel 1 kilometer, it will take a total time of 1.5 minutes, or 1 minute and 30 seconds. Therefore, to travel 100, it will be 100 multiplied by 1.5, which works out to be 150 minutes. And if you wanted to leave the answer in minutes, you could leave it there. That would be correct. Or if you wanted to convert it back to hours, then we know that 60 minutes make an hour, 120 minutes make 2 hours, and then there would be an additional 30 minutes. So then it would work out to be 2 hours and 30 minutes. And there's other variations in which you could actually approach the question to get the answer correct. So hopefully those two methods are one of which you chose, and of course if it works, it works. All right, so good going on that one, guys. Leave me a comment down below as it relates to what method you use and what method you thought was best. All right, so we're going to move on now to the remaining aspect of the paper. Let's go all the way, I believe all the way around here. We finished part of the. All right, so now we're at part B of question 3, and now we're tapping into the inverse proportion. All right, so hopefully you guys are familiar with inverse proportional formulas. All right, here we go. It says that if A is inversely proportional to the square root of B, and A is equal to 6.2 whilst B is equal to 4.7, you're to determine the value of B when A is equal to 15.3. And I think I had made an error here. I wanted to say, let me just correct it from now, when the value of B when A is 15.3 and the value of A, I believe I made an error here. I wanted you to find the value of B when A is 15.3, and I wanted to find the value of A when B is equal to 1.5. All right, okay, so here we go. All right, so when it comes to inverse proportion and direct proportion, this we must remember the two standardized formulas that we are supposed to know. And when it comes to direct proportion, we know that y is equal to k multiplied by x. That is direct proportion. And when it comes to inverse or indirect proportion, we know that y is equal to k divided by x, where k is your constant of variation and y and x are independent variables. Okay, now in this particular question here, we are looking at inverse proportion. So right away we know that we have to zone in on the formula that says y is equal to k over x. Now in this particular question, we are using two different variables to represent our variation. We are using a and we are using the square root of b. So naturally a is going to be the representative for y. So then the formula that we have to be using here is that a is equal to k divided by x is going to be represented by the square root of b. And so this is the formula that we're actually working with here. The formula that is reconstructed here. A is equal to the k, A is equal divided by the square root of b. Now, of course, to proceed into finding any values that is with this variation, we are going to need to establish the value of our constant variation. So we're looking for k. Now, initially, you'll see that they would have given you two initial values of a and b, where a is 6.2 and b is 4.7. Notice that they didn't give us a value for k. So we need to proceed to find that. All right. So since as we are told that a is 6.2, we know that we could set an equation here. All right. We could say here that that's 6.2 is equal to k divided by the square root of, I believe it was 4.7. All right. So I found that a lot of my students, they actually wrote down the correct formula, but they didn't write down the variation or the reconstructed formula. A lot of my students, they wrote that A is equal to K over B. They didn't write the square root, and that automatically allowed them to get the questions incorrect. All right, so if we go right ahead now and proceed into working this out, we'll find that the square root of 4.7 is actually 2.17 or 2.16. 2.17 when it's rounded off. So that's 6.2. That's equal to K divided by the square root of 4.7. It is 2.16. I'm just going to be using the unrounded off version. Okay. And so when our unknown is at the top, this is a little shortcut that I do teach my students when you want to just get to the answer really quickly. When you recognize that the unknown variable is the numerator, then we simply multiply the numbers that we see here. Okay, so therefore K is going to be equal to 6.2 multiplied by 2.16, and so that works out nicely here to be equal to let's see here, let's delete here. So that's 2.167 multiplied by 6.2, and that works out to be 13.44. So K is equal to 13.44. This is our constant of variation. All right. Now that we have the constant of variation, that's the key to proceeding to finding out what else they ask us for. Now here they're saying that we should determine the value of B. Now we are in search of B, but this time it is when A is 15.3. So now if we go back to writing our formula here, that A is equal to K divided by the square root of B, you're going to find that we are looking for B when A is 15, changed from 6.2 to being a different number. So that's 15.3, and we already established a value for K, 13.4, and now we are in B. Again, a lot of the students, they leave off the square. You cannot remove the square root from the variation formula because in the initial stage, A varied inversely as the square root of B. So that will remain. All right. Now, another shortcut that I did teach my students to minimize the amount of working out that they have to do is that, like here, when we say known is in the numerator, we multiply. When your unknown variable is in the denominator, we will switch the positions. So we'll bring the square root of B up to the top here, and we would bring the 15.3 down to the bottom here. So that's 13.44 divided by 15.3. Now, if you were to work it out the longer version, if you were to work it out the longer way, you're going to find that you end up with the same thing here, just have an extra line. All right. Now, as you go further and further into math, you're going to find that a lot of the steps you're going to have to skip out to make the working out a lot more efficient. All right. So now we end up with the square root of B is equal to 13.44 divided by 15.3. So that is 13.44 divided by 15.3. That works out to be 0.88 rounded off. So that's 0.88. Now we are in search of B. And remember, you cannot remove the square root from the formula. So it is at this stage now we are removing the square root requires us to square. So we would therefore say squaring the square root of B. And then we would go ahead now and square 0.88. The square will then cancel the square root, and we're going to be left with B. And that's going to be equal to, let's just square that up here. I think it was 0.77 or 71. Let me just double check on my calculator here. So that is 0.88 squared, 0.77 as predicted. So it's 0.77 is our value for B. All right, so hopefully you guys got an understanding. Remember that you must stay with the formula. When we earlier that A varied directly as the square root of B, once you're finding B, you have to bring that square root with the b until you get down to the last aspect of the problem, where you will find that you're gonna have to remove the square root there. Okay, and so just finally here, let's go to the last part here. We are now interested in finding the value of a now, but this time b is 1.5. So let's go back to our formula. This is part 3 here. So now a is equal to k divided by the square root of b. Please note that we are looking for a in this case, but this time k, as we had calculated earlier up here, to be 13.44, and now they say that b is 1.5, so it becomes the square root of 1.5. So if you take the square root of 1.55, you're gonna find that the square root of 1.55, or 1.5, pardon me, is equal to 1.22. So a then would have worked out to be 13.44 divided by 1.22, and then this works out nicely here. That's 13.44 divided by 1.22. You're gonna find that your answer is 11.01. all right, and that there is your final solution to this particular problem. Right, so that completes our variation there. Of course, what you can do though is try to work out the problem on your own going forward, and then press play to see the solution that I have provided to you here. All right, it's good to always attempt, and then once you have attempted the problem, then you can see where you went wrong or right. But don't just depend on the video to provide you with the answer. That's not improving your ability to do the math yourself. Make a mistake and get your correction and move forward. All right, so now we're going to move right along now into the remaining questions of the second paper. Hopefully you're getting some value, guys. You're getting some sort of value. So let's see how it goes going forward into the remaining questions. So here we're going to be doing this substitution problem. So I'll see you in a bit. Alright guys, so we're going to move on to now part C here, where we're now looking at, well, in fact I actually thought I was supposed to go to this question, but I had missed out this aspect of the paper here. So 3 bananas and 2 pears cost $10.50, whilst 4 bananas and 3 pears cost $14.35. Using B to represent the cost of a banana or cost of bananas, and P to represent the cost of a pear, write 2 equations to represent the above scenario and hence determine the cost of each fruit. Alright, so this is clearly an indication that we're going to have to work out this problem using the simultaneous equation method. Alright, simply because we are dealing with 2 different unknown quantities and we need to find the cost of each. So in order for us to do this, let's first use an indicator here. The banana is being represented by B and the pear is being represented by P. So the first thing here is that they told us that 3 bananas, all right, plus 2 pears would have cost $2.50. And if I remember distinctly, I believe they said here, let's just double check. I believe they said here that 4 bananas and 3 pears. So first it was 3 bananas and 2 pears. Now it's 4 bananas and 3 pears. So 4 bananas and 3 pears would have cost $14.35. Let's double check that here. 14.30, that is correct, $14.35. And that here would have been equation 2. Now for those who are familiar with the methods of simultaneous equation using the elimination method, you would have known that we need to equalize the middle term or the end term, preferably the middle term. All right, so here I would simply multiply this equation here by 3, and I would then multiply the top equation, the bottom equation, by 2. By using these two multipliers, it will find that after the multiplication, the two middle terms are going to be the same coefficient. So 3 multiplied by 3b, that's going to give us 9b. And 3 multiplied by 2p, that's going to give us 6p. And 3 multiplied by 1050, that's going to give us 3150. And that forms equation 3. All right, proceeding, 2 multiplied by 4b, that's going to be 8b. 2 multiplied by 3p, that's going to be again 6p, which is exactly what we wanted. And 2 multiplied by 1435, that's going to give us 2870. All right, 2 multiplied by 14 is 28. 2 multiplied by 0.35 is 0.70. That's equation 4. All right, now the aim in the first place was to get the middle term to be equal, which we have successfully done. And so because the signs of both of the terms are the same, then we are going to subtract in order to eliminate the pair value from the equation. So 9 bananas minus 8 bananas will give us just 1 banana. 6 pair minus 6 pair, that's going to give us 0. And so 31.50 minus 28.70, that's going to give us $2 and, pardon me, let's just double check that. I think it's $2.80. 31.50, take away 28.70. Oops. Okay. 28.70. That's going to give us $2.80. So that is going to be the cost of one banana, $2.80. Now that we know the cost of one banana, we can now use that information then to find the cost of a pear. So by substituting $2.80 for the cost of a banana in, and we can choose either equation 1 or 2, preferably I'm going to be using equation 1, but if you were to choose equation 2, it would be the same thing. We are now going to be able to eliminate the cost of the banana, which we now know, in order to find the cost of a pear. So in equation 1, we have 3b, so that's 3 times the value of b, which we now know is 2.80. And then we're going to be adding 2 pairs, that's 2p, that's going to be equal to 1050. All right, now 3 multiplied by 2.80, if I'm correct, I believe that is $8.40. All right, I believe that's $8.40 plus 2p, that's going to be equal to 10.50, $10.50. So basic equation, definitely bring that or transpose 8.40 to the right hand side, or in other words, we subtract 8.40 from both sides. We're going to be ending up with 2p being equal to 10.50 take away 8.40. All right, so 10.50 take away 8.40. I believe the answer is going to be 2.10, but let's just double check that again. So that's 10.50 take away 8.40, that's $2.10. So that's 2p is equal to $2.10. And if you were to divide both sides by 2, as we've been doing so far, here you're going to find that the cost of a pear is $1.05. All right, and that is how we go about solving that problem, that simultaneous equation problem. All right. So then we're just going to continue now and move on to the remaining problems. So again, guys, I hope that you're getting some value, and if you are, of course, be sure to leave a like and do not forget to share this out where you can help other students. Okay, so here we go. We're going to be working this substitution problem here. So given that x is equal to 2 and y is equal to -5 and z is equal to 3, we have to evaluate the following expressions. I should be able to do this problem within the space that I have here. So let's go about doing that now. So we have x take away 2 times the value of y. So x is actually equal to 2. All right. And then we're going to take away 2 times the value of y. So that's 2 multiplied by the value of y, which in this case is -5. Let's proceed here. 2 will take away 2 times -5. If you notice that the negative on the outside here belongs to the 2. So this is actually -2 that is multiplying -5, which works out to be +10. So it works out to be +10. All right, because the negative multiplied by the negative is a positive. And so 2 plus 10 is equal to 12. That was pretty easy. I found that a lot of my students did get that one correct. All right. Now we have here that x, the value of x is being raised to the power of z. So x, we are told that is 2. And we're going to be raising it to the power of z, where z is 3. And for some reason, I'm not sure, whilst I was marking a few of my students' paper, I found a lot of them putting like a subtraction sign here. Now, if you look at the expression here, it is x to the power of z attached to y. And we all know that once there isn't a sign visible between two variables, then it would indicate multiplication. So I found that a lot of my students gave up these free 2 marks here that they should have really gotten right, that they should have gotten correct. Quite a few students did get it correct, but quite a few did also get it incorrect. Okay, so 2 to the power of 3, we all know that's equal to 8. So that's 2 multiplied by 2 multiplied by 2. Again, quite a few students, I realized that they kept saying that 2 to the power of 3 is 2 times 3. We've got to get rid of that fundamental error there. So we can't do that anymore, guys, okay? So 2 to the power of 3 means 2 multiplied by itself 3 times. Times 5, and that works out to be -40. Okay? And so this last aspect here, 7 multiplied by x, that's 7 multiplied by the value of x, which is 2, plus 2 multiplied by the value of y, which is -5, divided by the value of z, which is 3. All right? That's 3. So if you work this out here, 7 multiplied by 2, that's going to give us 14. And 2 multiplied by -5, that's going to give us -10, divided by 3. So 14 minus 10 is 4, divided by 3. You can leave your answer as 4 over 3, or you can write it as a mixed fraction, 1 and 1/3, or you can write as a decimal, 1.33333. All right, so that also is correct. Okay, so good going there. That was a free 5 marks for a lot of my students, and that was good. So now we're going to move on to this aspect of the problem. Wherever I see it fit, where I can work it in the space that's provided to me, I will do so. Otherwise, I may have to go on a blank page here, guys. Okay. So now we're looking at some indices problem here, and this was very surprising to me, that I found that a lot of students, I'm not sure what they were looking at, but they actually converted the whole entire question into something completely different. All right, I'm not sure if they were paying attention to the question, but I find that students thought that 9 to the power of a half meant 9 and a half. And also 8 to the power of 2/3, they converted it to mean 8 and 2/3. So they turned it into a mixed fraction, which pretty much they went horribly wrong from the moment that they did that. So you have to understand that 9 to the power of a half is not anywhere close to 9 and a half. All right, you've got to look at how the question is written. Okay, so for those of you who actually did that, you know that's why you got the question incorrect. So anyways, 9 to the power of a half, it's indices and exponential indices with a fractional power. All right, so this would mean that we need to convert the 9 into a base. So we could turn 9 into 3 squared. And then because the square is a power and the half was a power, we would then go ahead now and multiply this back again by a half. All right, so that's 3 squared, which is the 9 raised to the power of a half. I think that I find it better doing this. That's 3 to the squared, all raised to the power of a half. Find it better doing that. All right, multiplied by 8 is now 2 cubes, which we earlier stated here that 2 cubes is actually 8. So 2 cubes is 8, and that now is raised to the power of 2/3. And then we all know that anytime you raise a quantity to the power of 0, the result is 1. But let's just write back the 4 to the 0 here and see what happens. All right. Okay, so now we can do some cancellation in the powers. The 2 on the square here will cancel the denominator 2 here, and the power 3 here will cancel the denominator here, which is 3. And we all know that 4 to the 0 is 1. So basically what we have here is just 3. That's 3 to the 1 multiplied by 2 squared. Here's the base 2, and here's the single power 2 here. So that's 2 squared, that's 4. And 4 to the power of 0, anything raised to the power of 0 is 1. All right, now 3 times 4 is 12, and 12 divided by 1 is equal to 12. All right, so it was a fairly simple problem if you know about exponential quantities. Of course, I'll be making a lot of videos when it comes to different variations in math, so just stay tuned, and once you see that notification pops up, definitely, if you are doing exams coming up in May of this year, then you definitely want to tune in to all the videos that are being posted on this channel, and be sure to share it out to everyone. Okay, let's move right along to the next question. All right, I may have to do this problem down into this space here, because this question here, solve the equation, is actually at the top. Yeah, okay, so here we go. So this now becomes 4c. Let me just change it here. Okay, so 4c squared multiplied by 3c to the 4th divided by c cubed. All right, so now we end up with 4c squared multiplied by 3c to the 4. We're going to multiply the coefficient, so that's 4 times 3 is 12. So that's 4 times 3 is 12. And we know that once we are multiplying variables that have the same base, we're going to be adding the power. So that's c, and we're going to be adding the 2 plus the 4. All right, and then we're going to be dividing the result here again by c cubed. Okay, now let's proceed here. We're going to find that this is going to be 12c raised to the 6 divided by c cubed. And now we have one final step here. We're now dividing, and the bases are the same. Yes, the coefficients are different. So 12 divided by 1 is 12. And the bases are the same, so that's c6. And because we're dividing, we're going to be subtracting the powers. So that works out nicely here to be equal to 12c cubed. 6 take away 3 is 3. All right, and that becomes your final result. All right, so let's definitely check out your indices law. I do have another channel that I usually create videos on, but I'm not putting any videos out on there because I'm currently just going through reconstructing that channel into becoming a college math channel. So this is the channel where you're going to find a lot of the CSEC, SEA, ED, Excel exams questions and CCSLC questions being posted here on this platform. The other platform is just going to be purely related to college math courses and stuff like that. Okay, so that brings us to the end of that particular question. We are almost at the end of the paper, guys, so just stay tuned with me a little bit more here and ensure that you go through the entire video and to make sure that you get the maximum value for your time. All right, so here we go. Now we are required, I believe the instruction here that says solve the equation, and the equation that was presented to us here was 7 take away 4x is, I believe 7 take away 4x is less than or equal to 15. So let's go on a separate page here. 7. All right, so that's going to be 7 take away 4x is less than or equal to 15. Now there's two ways in which this problem can be approached, and it kind of depends on what your first step is. I'm going to show you both variations to the problem. So here we go. First problem, first method, pardon me, 7 take away 4x is less than or equal to 15. The first thing that I do recommend that you do here, guys, is that you transpose the negative 4x. A lot of students, I find that when you're transposing, they tend to transpose the number or the variable and they do not transpose the sign that is in front of the variable. So here, I do recommend that you transpose the negative 4x to the right hand side so as to get the subject to be positive. Or what you're going to find a lot of teachers tell you is that you're going to add 4x to both sides. So if you were to say perhaps bring this across here, you'll find that 7, all right, and then once I'm transposing the negative 4x to the right hand side, simultaneously I'm going to be transposing the 15. So 7 will take away 15. Remember that if you transpose a term across the equal or inequality sign, the sign is going to change to its opposite. So 7 take away 15 is going to be less than or equal to positive 4x because negative 4x was transposed. Now 7 take away 15 will work out to be minus 8, and that's going to be less than or equal to 4x. Now let's divide both sides by 4, and you're going to find easily that you attain a result of x being greater than, when you're reading it from this direction, then x is greater than or equal to negative 2. If you're reading it from this direction, then negative 2 is less than or equal to x. Now I kind of prefer this method because in the other method I'm going to show you, I also find that a lot of students tend to forget this one very simple but easily overrated step, right? And I found that a lot of my students lost half mark and 1 mark from this exam because they forgot to do this exact thing here. Now a lot of the students, what they did is that they transposed the 7 across here, and that's fine. So that's negative 4x is less than or equal to 15. Positive 7 came across, became minus 7. So negative 4x is less than or equal to 15 take away 7. That's equal to 8. Now, because you are dividing by a negative number or a negative coefficient, I found that a lot of students forgot to reverse the sign. So they fail to reverse the sign, then it cost them a half mark, sometimes a 1 mark, sometimes it even cost them the problem itself because the answer should have been minus 2. I found that a lot of them wrote down positive 2. So x then becomes greater than or equal to negative 2. So you might be looking at both methods and you'll be like, aren't these two different answers? They are not. Because if you notice, the mouth of the sign is open on the side of the x. You'll realize over here that the mouth of the sign is also open towards x. So you know that it's being read in two different directions. Here I am saying that negative 2 is less than or equal to x. So obviously if negative 2 is less than or equal to x, then on the contrary, x would have to be greater than or equal to negative 2. Alright, so hopefully you got both methods. Let me know in the comment section down below what method you chose or what method you prefer. And of course, make sure that you use this to your best advantage. Alright, so let's hop on to the next question. So the next question that we're going to be looking at here is going to be, just a second here. So the next question that we're going to be looking at here is actually solving this next equation here, this fractional equation. I did realize that we didn't write the solution to that problem as a solution set, so let's just do that right now. All right, so here we go. We didn't write as a solution set. It says that x is actually greater than or equal to minus 2. So x is going to be such that x is a member of minus 2, minus 1, 0, and so on, because the list of values for this solution is infinitely many. We just simply do something like that and we just wrote infinity symbol, so the results will continue all the way to infinity, and that is your solution set. All right, now the next problem that we have to encounter here is the x minus 1 over 2. All right, so let's go to that now. So that's x minus 1 over 2. And might have to skip back and forth here, guys. Take away 3x minus 2 over 3. 3x minus 2 over 3. 3x minus 2 over 3. And if I remember correctly, it's going to be equal to x. So we're going to have to solve that equation. Let's just double check and make sure that we're on the right path. So it's equal to x for 3 marks. Okay, so here's how we're going to approach this question here. For this one here, we're going to have to find the LCM, but in the usual way that we would find the LCM and draw a line, I only particularly draw a line whenever I am simplifying, like I want an expression for my answer. Because I'm solving, I'm going to just kind of state what the LCM is. So the LCM here is going to be equal to 6. And then what I'm going to do is that I'm going to be using the 6 to multiply each of the variables or the expression that makes up this equation. So 6 is going to multiply, 6 is going to multiply the x minus 1 over 2. All right. And then I'm going to be using the 6 again to multiply the 3x minus 2 over 3. And then once again, I'm going to be using the 6 to multiply the x. So let's just put those in. So the 6, which is the LCM, is going to multiply the x minus 1 over 2. And as you can see here, I'm going to put down my minus sign here. And I'm going to be using the 6 to multiply the 3x minus 2 over 3. And then once again now, I'm going to be using the 6 now to multiply the x. Okay. All right. Now what I like to do is that when I'm doing this, I prefer to use parentheses. I like to use brackets. I really don't like to use the multiplication because it's kind of ambiguous. It literally sometimes misleads a student into using the 6 to multiply the first term and not multiplying the second term. So we've just got to play it safe and make sure that we write the problem or write down the problem in a way that will allow us to remember our fundamental principles. Now, you would have learned in previous contents that should you have a number that is outside of a parenthesis or a bracket, it's going to be used to multiply what is on the inside. So in this case here, Before I actually go ahead and distribute the 6's, I'm going to be canceling here. So if I can cancel here, let's see, the 2 will cancel the 6 3 times. And we have 2 lots of 3 that can come from 6. And there isn't anything to cancel out here, so we should be safe. So we can go ahead now and distribute the 3 here. And we can distribute the -2 here. And we can distribute the 6 here. Okay, so 3 will multiply x. We end up with 3x. And 3 is going to multiply -1. We end up with -3. Please note that this is a -2. If you look carefully, there's a minus sign there. So the -2 multiplies the 3x, gives us -6x. And the -2 is going to multiply the -2 again, and we end up with a +4. And that here is the exact area of the problem where I found that a lot of my students got this problem incorrect. They had -4 instead of +4. And so from there, they pretty much lost all possible marks that they could have attained. So you've got to be careful when you're distributing. Remember, you are distributing the number that is in front of the parenthesis, including the sign. Okay? Now, very basic form of equation here. Get the x's on the left hand side. So we end up having 3x already here. We have 6x already here. And we can transpose this positive 6x again to be 6x here. Now, we can go ahead now and transpose the 4. So we end up with -4 on the right hand side because it's now transposed across here. And -3 becomes a +3. So now we end up working out that 3x take away 6x is going to be equal to -3x. And -3x take away 6x is -9x. Alright? And that's going to be equal to, actually here, that's going to be equal to -1. Okay, so if you were to divide both sides by -9, we already know this, guys, that x is going to be equal to -1 divided by -9, which works out to be 1/9. Okay, so x is equal to 1/9, and that is our final answer. All right, so if you are having problems with equations, you definitely need to level up on your equation skills, knowing when to transpose, knowing when to divide, knowing when to multiply. It will make the problem a lot easier. But I'm definitely going to be doing some videos in terms of the fundamentals of solving equations that can assist you students in becoming better. But you definitely also need to put in the practice behind closed doors to make sure that your skills are maintained or they are improving. All right, so that brings us to the end of that particular problem there. So now what we're going to be looking at now is we're going to be looking at some, okay, we have one more equation here that we have to solve, this linear inequality. So now we end up with -2 open bracket p plus 3. Let's work on another problem, guys. -2 open bracket p plus 3. Just a moment here, guys. Let me just kind of get this out of the way. So that's -2 open bracket p plus 3. Let's go back to the page here. Make sure that we have a good look at this. And that's going to be greater than -35. So that's going to be greater than -35. So this is sort of similar to the very first example that we had worked out. It's a simpler version, but still very effective. All right. And again, there's 2 versions to this. I like to show my students both versions, right? So you can choose whatever method you feel best fit. So the first thing that we have to do here is to distribute the -2 here. -2 multiplied by p, that gives us -2p. So that's -2p. And negative multiplied by a positive value, that gives us a negative value. 2 multiplied by 3, 6. And that's going to be less than -35. Okay, so now again we are going to transpose. All right, we're going to transpose the -6 here, so that's -2p is greater than -35, and we transpose the -6 or add 6 to both sides, we end up with a +6. Now -2p is going to be greater than the result of -35 plus 6, which works out to be -29. And if we divide again both sides of the inequation by -2, remember that you're dividing by a negative in an inequality, so the sign has to be reversed. So that's -29 divided by -2. You're going to find that p is less than +29 over 2. All right. Now an alternative to this would have obviously been, again, we have to distribute, so that's -2p minus 6 is greater than -35. Alternatively, rather than transposing or adding 6 to both sides, we can add 2p to both sides and add 35 to both sides. It's a little bit more complicated, but I do recommend that at all times try to ensure that your subject that you intend on solving for is always positive. So I strongly recommend that every time that you get an equation or an inequation to solve, ensure that there isn't a minus sign that is in front of your subject. But in this case here, if I transpose the -35, I'm going to get +35. Take away 6 is now greater than +2p. Now this is 29 is now greater than 2p. So if you were to divide both sides by 2, you'll find that pardon me here, p is going to be less than 29 over 2. I attain my result quicker. All right, now again, you might be looking at this and you'll be like, oh, there are two different answers. Notice that the mouth of the sign is closed towards the direction of the p. So you can see that it's also closed towards the direction of the p. Again, you can see that they are the same result. As to which method you prefer, that's a personal choice. You do what is best suited for you. All right, so those are the two methods for solving that particular problem. Now, we are finished with equations. We're going to move on to some factoring. All right, we're going to move on to some factoring. Let's go back to that page here and let's see what we can get. So we're going to be looking at factoring the following expressions. Factorization, major topic in CSEC. Hopefully we can run through these 4 in this aspect of the video. All right, so here we go. 16x squared y cube. All right, so let's just get the questions down here. 16x squared y cube. And take away 8x y to the power of 5. 8x y to the power of 5 plus, pardon me guys, I may have to go back and forward like that, but I don't have all the questions on one page, plus 12y. Okay, so that's plus 12y. We're gonna have to factor that. Just to be close, let me just rewrite the remaining questions on the same page. Let's just do a little bit of transfer here. So 50 take away 8x squared. 50 take away 8x squared. I believe the other one was 4x squared minus 19x. I believe it was. Let me just double check on that. 4x squared minus 19x plus 12. And if I remember correctly, which I don't actually. The final question was 3a plus 80. 3a plus 80 minus 6p minus 2pt. Minus 6p minus 6p plus 2pt, I believe. So I'm a little bit closer to skipping the pages. So the first problem here would have been 16x squared y cubed. Pardon me, guys. 16x squared y cubed minus 8xy5 and plus 12y. So with this particular factoring method here, this is just the highest common factor method. All right, we're looking for terms or coefficients that are common throughout. All right, the highest common factor for the expression. Now I like to sectionalize this, and I like to tell my students to factor the number or find the HCF of the number, find it, and then find the HCF of the individual letters, variables, pardon me. So 16, 8, 12, the highest number that could divide into all three would have obviously been 4. All right, we'll take a look now and to see if all the x's are spread out evenly. We see that there's an x square here, there's an x here, but unfortunately there isn't an x here, so therefore x is not going to be a part of the highest common factor. We have y cubed, we have y5, and we have y to the power of 1. So clearly the variable with the lowest power is going to be a part of your HCF. Okay, so 4y, open a bracket here, and we're going to be using the 4y to divide the expression to see what is left. So 4 into 16 goes 4 times. 4 into 16 goes 4 times. All right, and then we know that the x square is not going to be we're not going to make contact with the x squared, so that returns. And so y into y cube is going to give us y squared times, simply because once we're dividing, we're going to be subtracting the powers. So the power here is 1, 3 take away 1 is 2, and so what is left is y squared. Take away, let's divide the 8xy to the 5 by 4y. So 4 into 8 goes 2 times. Once again, x is not a part of your HCF, so it's not going to be, we're not going to make contact with that. And so y5 divided by a single y is going to give us y4, y to the power of 4. Plus here, 4 into 12 goes 3 times, and y into y goes 1 times. So 3 times 1 is just simply 3. And there isn't anything much that we can do to the equation at this point in time. There isn't anything else that we can do. There's nothing to add. There's nothing to subtract. There's no like terms. There isn't anything there. Okay? And so we're going to move on to the next question. So that completes that factoring method. All right. So now we're going to move on now to 50 take away 8x squared. And this also is another very interesting factoring method here. All right, so now you can see that it kind of comes off as being a difference of 2 squares. If you're familiar with a difference of 2 squares, you will know that the difference of 2 squares has the general formation x squared minus y squared. Now the problem that we're having here, why it isn't immediately a difference of 2 squares, is because there is no number that you can actually square to get 50, and there is no number that you can square itself to get 8. But if you look carefully, that there is a common factor that is divisible into 50 and 8, and that's clearly going to be 2. So if we take the 2 and we divide into the 50, we should get 25. And we take the 2 and we divide into the 8, we should get 4. And clearly, x squared is going to be left. Now, if you look closely zoom up here of what is in the bracket, you're going to find that there is actually a number that you can square to get 25. That's 5 squared. And there's actually a number that you can square to get 4, so that's 2 squared. And we all know that x is already squared, all right? So now you can see that it has that general formation of a difference of two squares. That is x squared take away y squared. All right, so that is now where we can go a bit further. Right now, I found that quite a bit of my students, they left it at this section. They only got a mark or a half mark, right? But you needed to go a bit further, because with a difference of two squares, we all know that after factoring, the result is going to be x plus y and x minus y. That's the result. All right, that can be proven in another video. But for now, the explanation behind this here is that once you end up with an expression that is the difference of two squares, you're going to find that the result here is x plus y by x minus y. So this now will mean that this is open two brackets here, and you're going to have 5 plus 2x and 5 take away 2x. And that clears up that particular problem there. All right, so that is completely factorized. All right, so we're going to move on now to the quadratic expression, which is going to be 4x squared minus 19x plus 12. I did a video. I will link a description down below. I mean, there's not a lot of videos on my channel currently, so you can definitely check out the video about factoring, where I spoke to you guys about how to factorize expressions like this. Do check out that video. Hopefully it's of benefit to you. So here we end up with 4 multiplied by 12. I'm just going to move a little bit austere, guys, because this was already done on my channel. If you're a new subscriber, do check that out. If you're not new, you should be familiar with this method here. So 4 multiplied by 12 is 48. All right. And if we break down 48 into a couple of different factors, you'll find that, of course, 4 and 12 is a factor. 16 and 3 is also a factor. 24 and 2 is also a factor. And 48 and 1 is also a factor. All right. 48 and 1 is also a factor. But clearly we're looking to get the result of minus 19. So now we're looking at 16 and 3 being the factor. So it's going to be minus 16 and minus 3. That will produce minus 19. And of course, minus 16 multiplied by minus 3 will produce the result of positive 48. So now we end up with 4x squared. Take away 16x. Take away 3x plus 12. Alright? Now by factoring, by grouping, we're going to group the first two terms and factor them individually. So if we factor from the first two individuals here, from the first two variables, or first two expressions, pardon me, here and here, you're going to find here that the common factor between 4x squared and 16x is actually 4x. So that's going to be 4x is the common factor. All right. Because x is common to both, 4 is common to both. 4 into 4 cancels. X into x squared goes x times. 4 into 16 goes 4 times, and the x cancels the x. So we have factored that first bracket there. The common factor for 3x and 12 is going to be 3. And if we divide negative 3 into negative 3x, we're going to get x. Negative divides into positive, gives us a negative 3 into 12 goes 4 times. But please note that whatever is in this bracket always usually ends up to be in this bracket here, or parenthesis here, so we should be okay. Common factor now is going to be 4x take away 3. And the repetitive factor here is going to be x take away 4. Alright, that is the factor there. And that has been factorized. Alright, so that lies that problem there. So hopefully you're getting some value, and you have just improved a little bit on your factoring method there for quadratics. A link will be in the description box below for a video that explains the factoring technique for quadratics in full. So do check that out. We're going to hop on to the final factoring problem. So the next problem that we're going to be looking at here, guys, is this next one here, 3a plus at minus 6b plus 2pt. And so this is just basically factoring by grouping, kind of similar to what we actually did in this line over here. It's kind of the same thing, except that we're dealing with more than one. We're dealing with different variables, so it's the same procedure. We're just going to be grouping this into twos. So we're going to be factoring the first two, factoring the second two, and see what the common factor is going to be. So first factor here, what is common between 3a and at? We're going to find that the result here is going to be a. A divides into 3a will leave us with 3, and a divides into at will leave us with t. All right. Then we're going to find over here that the common factor between these two here, numerically, it's going to be -2. And you can see that variable wise, it's going to be p. Now, -2 goes into -6 3 times, and the p will cancel the p, right? And negative, I believe, pardon me, right? I believe this is a negative sign. All right, that's supposed to be a negative sign. So negative into negative goes positive, and -2 into -2 cancels, p cancels p, and we are left with t. All right, pardon me here, guys. The sign that's supposed to be here is a minus. We can confirm that by just going back over here. This is supposed to actually be a minus. And just to show you, just to make certain that you see that the problem is actually, when we were writing it down, we realized that this is supposed to be a minus right here, as you can see. So that was my error. Okay, so here we go then. The common factor works out here to be 3 plus t. As you can see, that's the factor that's repeating itself here and here. Okay, and the remaining factor is going to be a take away 2p. All right, so that there completes the factoring. All right, so that brings us to the end of that segment of the paper. We're going to move on now to the wrapping up the final aspect of the paper now, which is simplification process. All right, so now we're going to be doing some distributive law and some making different variables the subject of a formula. All right, so once again, here we have 2 plus, I don't have enough space here, guys, so I'm going to have to go again on a separate page. So we have here 2 open bracket x plus 3y Alright, so we have 2 open bracket here, x plus 3y, and that's going to be added to 3x open 3x take away y plus 5 in bracket. So that's going to be plus 3x take away y, or 3x take away open bracket y plus 5. All right, so that's the first simplification problem here. This is somewhat of an easy problem, but I find that a couple students, or quite a few actually, after distributing successfully here, 2 times x is 2x and 2 times 3y is 6y, I found that quite a few students actually use the 3x to distribute all the way over here. All right, number 1 rule when it comes to distributive law, it is supposed to be the term or number that immediately precedes the bracket that should be used to multiply what is inside the bracket. If it's too far away, it cannot be distributed. Now, what I think spook a lot of my students is that they didn't realize that there's a 1 here. All right, you have to understand that if a sign is in front of a bracket without a visible numerical value, then the numerical value that is understood is a -1. A lot of the times I hear quite a few teachers will tell you that you can distribute a sign, which is so, but when they say distribute a sign, they mean that you're going to be distributing -1. All right, -1, because we all know that 1 will not change the value of what is in the bracket or in the parenthesis. So we say we distribute the sign. Okay, so what we needed to do here was just kind of, pardon me, we needed to kind of write down the 3x here. So that's going to be plus 3x, and we're going to distribute here the minus sign. So that's minus times y, that's minus y, and minus times 5, that's minus 5. So that was what was required. So now we can just basically group like terms here. That's 2x plus 3x. Then we're going to group the y's together. That's 6y, take away y, and that's going to be plus 3x. Okay, pardon me, we had an extra 3x here, so let's go again. We have 2x plus 3x here. We have 6y, take away y, and then we take away our 5. And like terms here, 2x plus 3x is 5x. 6y minus y is actual 5y. And there's just a constant here of minus 5. So that there lies our final result. Alright, that's for the simplification aspect of that particular problem. Alright, so hopefully you guys are getting some value there. Let's go on to the next question that we're looking at. And this next question here is 5x take away 3 over 9. So that's 5x take away 3 over 9. 5x take away 3 over 9. And I believe that's going to be take away from, let's look here, 2x plus 1 over 4. 2x plus 1 over 4. Right? So this is basically a fractional simplification problem, and this basically requires us here to find the LCM. Now I did say to you earlier that there are times when I will draw a line and there are times when I will just write down the LCM. Here I am not solving, I'm simplifying. So this will require me to actually draw a line here and state that my LCM here is going to be 36. Now, let's go ahead here and we're going to divide the denominators into the LCM. So 9 divides into 36 goes 4 times. Now, I did see a few errors in terms of, I found that students would say 9 into 36 goes 4 times and they'll put the 4 here. Now, this is a little bit ambiguous because what this will imply is that the 4 will only multiply the 5x. So if you're not disciplined enough to remember that the 4's should multiply the 5x and the minus 3, you might find yourself making very, very basic errors, and that will definitely cost you marks, probably cost you the whole entire marks affiliated with the question. So what you want to do is that once you divide the 9 into the 36 and you get the result, take the result, put it on the line and multiply it by what is at the top. And I would prefer and do strongly recommend that you write it down as you see it here. 9 into 36 4 times, and you put the numerator, the expression that is in the numerator, into a parenthesis. Now, what that will do is that prior to a topic like this, you would have and should have been taught that whatever is on the outside of a parenthesis should be used to multiply everything that's inside, which was emphasized in the previous question. So here again, 4 into 36, again, we put down 9 times. And the numerator, the expression that is in the numerator is 2x plus 1. So that's where we're at here. And we put that into a parenthesis. Now, all we have to do now is just simply follow the basic rules of distribution. Distribute what is inside the bracket here. Distribute what is on the outside of the bracket, pardon me here. Alright, so we have 4 multiplied by 5x, that's going to give us 20x. And 4 multiplied by minus 3 is minus 12. Minus 9 times 2x is minus 18x. And minus 9 times 1 is minus 9. Do not forget to rewrite your denominator because you're not solving an equation, you are simplifying the expression. Let's take it up a notch here to the top. We're going to group like terms here. So we end up with 20x and we're going to put the 18x here. I think I'm running out of space here, guys. So let's see. All right. I did run out of space, guys. But let's just see if we can get it up here. So that's 20x, take away 18x. And that's going to be minus 12 minus 9. and that's going to be all over 36. So if we were to say 18x from 20x, that's going to give us 2x. And negative 12 take away 9, that's going to be negative 21. Please confirm that on your calculator. I also found that a lot of students keep ignoring the sign that is in front of the number. So quite a few persons did wrote down that the answer was 2x minus 3 over 36, pardon me, when the answer is in fact 2x take away 21 over 36. All right, so questions like these, usually if you're going to get these questions wrong, it's going to be in terms of you multiplying the incorrect sign, or you just simply writing down the problem in an ambiguous way, and you just have to be careful of how the problem is written down. All right, so just be careful and just make sure that you put a lot of practice in when it comes to problems like these. Okay, let's move right along to the next question. Again, if you haven't hit that like button as yet, please go ahead and do so right now, so that you can get some value from this video and let me know that it is benefiting you in some way, shape or form. Here we go. We're moving on next to this problem. I think I have enough space. Do I? I don't think I have enough space. I don't. So that's 4 take away 5 open bracket 8x minus 3. 4 take away 5. So that's 4 take away 5 open bracket 8x minus 3. And that's therefore going to be multiplied again here by 2x take away 1. That's 2x take away 1. And so this is a problem that is just testing your ability to distribute and expand brackets. All right. Now, there's a couple of ways that this can be done. I'm going to do it the way that I actually showed my students how to do it on the exam. I do recommend though, I strongly recommend that should in the event that you end up with a problem like this, you want to expand the brackets first. All right. You do not want to distribute and then expand the bracket. It makes the problem a little bit, a tad more difficult. So I do recommend what you should do here is that you would just simply distribute and expand the brackets that are joined together. And we would use what is known as the Bird-Beat method. All right. So then I would go ahead now and I would rewrite the 4. I would rewrite the minus 5. And what I'll do is that I'll open a huge parenthesis here. And then I would expand the 8x minus 3 by the 2x minus 1. That's what I recommend. All right. So here we go. 8x is going to multiply the bracket on the right. That is 2x take away 1. So the 8x, this is the first term, is going to distribute into the bracket on the right. And then the minus 3, once again, is going to distribute into the bracket on the right. So that's minus, that's 2x minus 1. That's how we're going to go about doing so. All right. So we split the first bracket into 2 single terms and then distribute it with the second bracket here. We would then proceed now to say 4 take away 5. 4 take away 5. Open bracket here. And then we're going to be distributing the 8x here. So that's 8x here. So that's 8x multiplied by 2x. That's going to give us 16x squared. 8x is going to multiply minus 1. That's going to give us 8x. Negative 3 multiplied 2x. That's negative 6x. And of course, negative multiplied by negative is a positive. 3 multiplied by 1 is 3. And we then close our brackets here. Now, once we have successfully done that now, guys, then we can now distribute the minus 5. So the minus 5 then would be distributed amongst all the terms here. Okay, if you wanted to, you could actually write another line and simplify the minus 8x with the 6x here, just to make the distribution a little bit easier. But tit for tat, mangoes is equal to tomato is equal to tomato. All right, so either ways you do it, you're going to get the same result. So here now what we have is 4 take away the distribution of negative 5. So negative 5 multiplies 16. That's going to give us 80x squared. The negative is going to distribute this negative here. So you should end up with a positive. That's 5 multiplied by 8 is 40x. Negative distributes the negative again, you end up with a positive. 5 times 6 is equal to 30. X. And of course, you can find here that negative times positive is negative. 5 times 3 is 15. Alright, so now we are good to go. All we have to do now is to look for the terms that are alike. We'll realize that there's nothing to group with the negative 80x squared. You can realize that 40x and 30x are like terms. So adding those, you should end up with 70x. And 4 take away 15 is equal to negative 11. And that there simplifies our expansion. All right, the other method is more or less the same, with the exception that I found that a lot of students immediately what they did is that they distributed the 5 with the first bracket. And to me personally, even though it's another method, I just feel like that's a little bit tedious. All right, I just find that if I can expand those two brackets that are joined together, then everything else sort of just looks like the fundamental principles. So I don't have to do much work on that there. Okay, so hopefully you guys got some value from that. Of course, make sure that you're already subscribed and you have hit that like button. And do not forget again, guys, to share the content out to wider population. We're going to be going through a lot of papers like these that will give you a lot of value when it comes to exam papers. All right, now we're moving on now to the final part of this question here, which is looking at the subject of the formula. All right, so here we go. 1 over r minus t over 2. All right, so that's 1 over r minus t over 2. So that's 1 over r minus t over 2. And that's going to be equal to, I believe it was something over v. Was it? Let's double check on that. It was 2 over v, as expected. That's 2 over v. So with a problem like this now, where we are making something the subject, I believe what we wanted to make the subject of the formula, according to the question here, we are required to actually make, we're actually required to make t the subject of the formula. All right, so in order for us to make t the subject of the formula, what is meant by making something the subject of the formula? The idea behind that is that we need to isolate the variable t. We need to get t to be by itself. Then there's a couple of ways which I'm going to show you how you can actually go about working this problem. So let's just do that here. On the left side, that I actually did it on the exam to show my students. Here, what you do is that you would again identify the LCM. It's kind of similar to the problem that we did earlier, where, let me see if I can go back to that page, where I said to you that I do not find LCM when I'm actually solving an equation. What I'll do is that I will highlight what the LCM is. Let me see if I can find that problem. I think it was around here, was it? Right, this was the problem that I was doing, where I said to you that when I'm finding the LCM, I do not actually write down or draw a line because it's an equation. I would just state what the LCM is, and then I would use the LCM to multiply each of the variables or the terms that are in the equation. So it's kind of similar here to what we're doing, except that we're not actually going to get a numerical value for our answer. We're going to actually get an expression for our answer. So here, the LCM, once again, is going to be equal to the product of the denominators, which in this case here is going to be 2RV. 2 multiplied by R multiplied by V gives us 2RV. So here, we would take the 2RV and we would then multiply it by 1 over R. We would again take the 2RV, just like we were taking the 6, to multiply every term. So we multiply the 2RV by T over 2. And we would then therefore go ahead now and multiply the 2RV by the 2 over v. Alright, this is supposed to be an equal sign. Alright, I won't be able to show you the other method, guys, but I'm sure that it's a variation of what is expected here. So here we go, guys. We're going to be cancelling out the terms now just to make it easier, because the idea is that we need to get rid of the denominators. So the r will knock out the r here, the 2 will knock out the 2 here, and the v will knock out the v here. So notice that there isn't any more denominators that's left. So now what we have now is just 2 multiplied by v multiplied by 1, that's 2v, and rv multiplied by t gives us 2, sorry, pardon me, that gives us rvt, and therefore that is equal now to 2r times 2. 2 times 2 is 4, so that's 4r. Remember, the aim is to isolate t. So to isolate t, we need to get rid of this 2v from this side here. Now, as you can see here, my subject is negative. So rather than transposing the 2v, leaving my subject negative, I'm going to instead transpose the rvt over here and then bring the 4r over here. All right. And so what that does for me now is that I'll end up with 2v. I'll end up with 2v. Take away 4r. And that's equal to positive rvt. All right. And now once my subject is positive, I'm feeling a bit safe. So all I have to do now is to isolate the t by dividing both sides of the equation by rv. So my final result here is 2v take away 4r divided by rv, and that's going to be equal to t, because once I divide the right side by rv, the two rv's will cancel, leaving me with t. And so that there is my final result. T is equal to 2v take away 4r over rv. All right, so that pretty much brings us to the end of the exam paper. There's actually another question, but I won't be able to do it in this upload. But you may be able to find the link to the PDF file that contains the document with the solution. All right, so until next time, guys, I want to thank you all for tuning in to this video and watching in its entirety. I hope you got some value. Make sure that you have liked the video. You are going to share the video to your other friends who need assistance with math. And of course, all my information and contact details can be found in the description box below, and links to other videos that you can work on. All right, do take care until next time. My name is Akin, your math guru. I'll see you in another tutorial video. Peace.